Okay, we continue with the example 4. A 4 ohm resistor and 8 ohm resistor and a 12 ohm resistor are connected in series with 24 volts of battery. So how many resistors you have here? 3. Very good. Here will be R1, here will be R2, here will be R3. The unit is ohm. Okay, for resistor connected in series with 24 volts of battery. So B. What are the equivalent resistance? So total resistance. Oh, for question A, what are the equivalent resistance? So this resistor connected in series. So how to calculate in series? Series, you just add all the resistor, right? So for question A, R equivalent is equal to R1 plus R2 plus R3. So 4 plus 8 plus 12, 24 ohm. R equivalent. Settle for A. B. The current in final resistor. Final resistor means you have to use R equivalent. So for B, find the current in final resistor. So equation of in resistance is Ohm's law. So V is equal to IR. So V given 24 volts. Current you have to find in the final resistor. Final resistor means the equivalent resistor, which is 24. So current is equal to 1 ampere. Okay. Repeat for the case in which all three resistors are connected in parallel. Parallel. So parallel, you have to use this equation. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So to calculate resistors in parallel, 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R equivalent is equal to 1 over R1 is 4 plus 1 over 8 plus 1 over 12. R1, R2, R3. So 1 over R equivalent is equal to, calculate how much? 1 over 4 plus 1 over 8 plus 1 over 12, 11 over 24. So R equivalent is equal to 1 over answer, 2.18 ohm. Okay, R equivalent for parallel circuit. Repeat the case in which are connected. Okay, so first you have to find equivalent resistance in parallel. Next, the current in final resistance. So V is equal to IR. V voltage how much? 24. Current you don't know. R 2.18. R, this one R equivalent for parallel, just now for series. So I is equal to 11 ampere. Okay, if in series, the equation just add all the resistors. So here how you do it. The current in final resistors, so this R will be R equivalent. So for parallel, 1 over R, this is the equation for parallel. You have to show all the steps here, and please write the equation before you start calculation. Okay, and the last example here will be the complicated circuit. It's not complicated actually, it's so simple. Find the equivalent resistance between points A and B. So points A and B will be connected with the battery if they connected with the battery. So first find the equivalent resistance between points A and B in figure below. Calculate the current in final resistor if the voltage is 34. Okay, so in this circuit, it's a combination of parallel and series, right? So you have to simplify the circuit. So which one you want to simplify first? Very good, this one. What is this? Up and down, and there's a junction here. If there's a junction between these two, so we call as parallel resistor. Parallel. So how you calculate parallel? 1 over R. So 1 over, okay, I label R1, R2, R3, R4. So 1 over R23 is equal to 1 over R2 plus 1 over R3. So R23 is equal to 1 over 7 plus 1 over 10. So R23 is equal to 1 over 7 plus 1 over 10. 1 over answer 4.12 ohm. Okay, so R23 4.12 ohm. So you will draw a simplified circuit. You will get this kind of circuit. Okay, V. So here will be 4 ohm, which is R1. Here R23, which is 4.12. Here will be R4, which is 9 ohm. So it become what? Series circuit, right? So series equation is R equivalent is equal to R1 plus R23 plus R4. So R1 is equal to 4 plus 4.12 plus 9. So 17.12 ohm. So this is equivalent resistance for this circuit. Okay. Okay, next, calculate the current in final resistor. Final resistor, you have to find current, equivalent resistance, which where you have potential difference of 34 volts. So it means it's connected with the battery here with the value of 34 volts. So find the current. So V, for question B, V is equal to IR. Voltage is 34. Current you don't know. R, this one, the total one, 17.12. So I is equal to 34 divided by 17.12. 1.99 ampere. So this is the current go through the final resistor here. Current. If in series, the current will be same, 1.99 for the whole circuit. Okay, so that's all for current and resistance. This is the summary of this chapter. You should know how to find current if you have charge flow within the time. Okay, rate of the charge flow. If you want to find resistance, you can use Ohm's law. If you want to find resistivity of the material itself, different material you will have different resistivity, so you can use R is equal to rho L over A. Area will be area of the cross section of the wire, which is pi R squared. Everything should be in SI units. Okay, if the resistor connected in parallel, so this is how you find resistance. If the resistor connected in series, you just add all R1, R2 and R3. Okay, so that's all for today. Thank you very much.